Hello, this is Kathy Dixon. Welcome to the Math Reflective. I'm a 6th grade teacher in Illinois, and I'm so excited about my afternoon today. It was just one of those days where all of a sudden something happened in my classroom today that completely pumped up my adrenaline, got me so excited. I even did like a little happy math dance, and one of my students said she was laughing because she saw me get so excited about math. So I really want to share this with all of you today. Do you ever have one of those lessons where all of a sudden a student is solving a problem and you're looking at it and you're thinking, how did they do that? What does this even mean? And does this connect to what we're doing right now? How can this be? Stay tuned. Well, let me back up a minute. I'm talking about my 6th grade standard math. And in our school, we're using Open Up Resources 6-8 Math, which was authored by Illustrative Mathematics, and we love this program. It's an inquiry-based program at our school, and we love implementing it with our students. So right now, we had just finished Unit 3, and that was on rates and percentages, and then we had jumped ahead to Unit 7 to cover GCF and LCM. So we had done a few lessons. It's lesson 16, 17, and 18, and we were on lesson 18 today, and students were solving problems where they had to figure out, am I finding greatest common factor to help me solve this? Am I finding least common multiple? So I was walking around the room, partners were working together, and I'm looking at a student's work, and he should have been using greatest common factor to help find a solution for this problem. But he used least common multiple. So I start looking at his work, and then he says, but wait, doesn't this, and he's explaining, and one of the questions he answered correctly. So then I started thinking, wait, could this work? How did he use the other way, the other method, to solve this problem? So I asked him a couple more questions, and then I was like, wait a minute. I went and got my co-teacher, Mary Dooms, involved because I said, you have to see this. Because what ended up happening is we stopped the whole class, called them back to their seats. It was so exciting. Today is about building our knowledge together and communicating about the different paths to a solution and understanding the structure of numbers. Okay, I want to start by reading the problem that I'm going to have Danny talk about his work. This problem is about tiles. A restaurant owner is replacing the restaurant's bathroom floor with square tiles. The tiles will be laid side by side to cover the entire bathroom with no gaps, and none of the tiles can be cut. The floor is a rectangle that measures 24 feet by 18 feet. Again, this is grade 6 math, Unit 7, Lesson 18 of Open Up Resources 6-8 Math. All right, so I want to introduce you to the very special student who amazed us yesterday in math class. This is Danny.
Hi.
And Danny is going to go over his thought process with this particular problem that we were working on yesterday with greatest common factor and least common multiple. All right, I have to start by actually apologizing to you, Danny, because yesterday when I first looked at his work, it looked incorrect. And I was about to start questioning him and using prompts to get him to think about greatest common factor as the way to solve the problem, because that is, typically what someone might think of when it was asking, like, what is the largest number or side length of a tile? So I have to apologize to you. I'm sorry that I did not recognize your brilliance right away, but let's go ahead and you can talk through how you saw this problem.
Okay, so here it says 24 feet by 18 feet. And here's where I started. I took the 24 and 18 and I started listing multiples of 24 and 18. So I got 24, 48, 72, 96. And then for the 18, I got 18, 36, 54, 27, or 72, and 96. So my first common multiple was the 72, which was the LCM. So then when I was over here, so 24 times 18 is 432, and the reason I did that is because 24 and 18 feet are the floor rectangle. So then what I did is I times that, I multiplied 24 by 18 so that I got an area total of 432.
I think that is so interesting that you found area as a way to solve this problem. Keep going.
So then I divided that by 72.
Which was your?
6.
Yeah.
But then that's not the whole answer because it says square tiles. So technically it's a 6 by 6 square.
Excellent. Okay. And what made you think of finding the area and then dividing by least common multiple? Did you know that would get you the correct answer to what's the largest size tile needed? Like, how did you, was it accidental?
Honestly, I think it was completely accidental, and I just figured out a way after that to get the right answer.
At this point, I wanted to see if he was really onto something, if this would work anytime. Could he use this process anytime? And Mrs. Dooms had the brilliant idea of, let's look at a problem we had done a few days before and use Danny's thinking, and he can walk us through that and we'll see if it works for that one too. So I'm going to cut over to that document now on my iPad and do a screen recording so you can see how that went. Okay, so this was a prior lesson that we were doing on greatest common factor, and the problem says a rectangular bulletin board is 12 inches tall and 27 inches wide. Elena plans to cover it with squares of colored paper that are all the same size. The paper squares come in different sizes. All of them have whole number inches for their side length. What is the side length of the largest square that Elena could use to cover the bulletin board completely without gaps and overlaps? Explain or show your reasoning. This is actually Danny, the same student's work from the week prior when we were doing greatest common factor. And you can see he did solve it using greatest common factor. He found all the factors of 12 and 27 and found the greatest common one would be 3, so it would be a 3-inch by 3-inch square. Now let's try the way that Danny did with this most recent lesson using least common multiple. As you can see, I took the time to prepare ahead and put the multiples of 12 and 27. And when I'm looking at this, I see that the least common multiple would be 108. When I was actually in the classroom that day, I ran over to the dry erase board as we pulled up this problem. Mrs. Dooms and I were just talking it through. She was sitting in the chair next to Danny, and I was furiously writing on the board saying, oh my gosh, is this gonna work? Is this gonna work? So what we did next is we did what Danny said about finding the area. Length times width would be 12 times 27, and that equals 324. And then divide by Danny's LCM for those two numbers was 108, and that's the LCM, and lo and behold, that does give us the 3, which is the greatest common factor and happens to be the side length of the largest square that Elena could use to cover the board completely. It's not like it was a huge surprise to me that somehow greatest common factor and least common multiple are related. I just needed to dig deeper. So I started to even just look at the 3 here that I found. The number opposite it would be 4. So there would be 4 going along the 12-inch side of those 3-inch squares. And then, of course, there would be 9 of the others. And that gave me the 12 and the 27. And I just started to try to see different ways to connect these numbers and how they work. As we had to get all the students kind of back to the lesson. So what we did is we pulled them in and we started talking about Danny's way of thinking and then showed them how it worked. They actually were sitting there witness to all of that when we talked. But we did need to wrap up our lesson. And what happened is after school that day, I started to think more about it, and so did Mrs. Dooms. And then I'm going to switch over to her, and she's going to share how she showed that they're connected. We knew that, of course, factors, as you are multiplying a number out, factors and multiples are related. But we just wanted to dig a little deeper about that.
Let's take a look at Danny's brilliance through the lens of prime factorization. Here you can see on the left, I have taken 24 and I've created a factor tree, and I have determined the prime factorization for 24 as being listed as these 4 numbers here that I've circled in red. So prime factorization for 24 would be 2, 3, 2, and 2. For the right, I have taken 18 and I've created a factor tree. And in that factor tree, I have listed the prime factorization of 18 as being 3, 3, and 2. And those are those numbers listed and identified in the circle on the right. Now, to find the greatest common factor between these two numbers, I have to look to find what numbers are in common. So I'm going through the list here for 24. I see a 2 is a common factor with 24 and 18, so I'll write 2 under the Venn diagram in the center. Another factor that's in common is 3, and so I account for that. And now those are the only other factors that are in common. So the greatest common factor for 24 and 18 is going to be the product of 2 times 3, which is 6. So the greatest common factor of 24 and 18 is 6. Now let's take a look at the least common multiple. I need to account for all the numbers that are listed in terms of the prime factorization that haven't been accounted for. So for 24, the numbers that haven't been accounted for yet are 2 and 2. And the only other number that is not accounted for on 18 is 3. What I'm going to do is to find the least common multiple is that I am going to be multiplying all of the prime factorizations. So I'm taking the 2 times 2 times 2 times 3 times 3. And when I multiply that together, I will get 72, which is the least common multiple. Now let's see Danny's brilliance and how that comes into play with this. So if we take a look at what Danny has done, Danny took the area, which is 432. He multiplied it by finding it by multiplying 24 times 18. Then what Danny did is he took that area of 432 square feet and he's dividing it by 72, the least common multiple, and then that results in a value of 6 to be determined as the greatest common factor between 24 and 18.
Okay, Danny, I appreciate you so much and your contributions in our classroom, and I would love to know what did that feel like to you as a mathematician yesterday? First of all, when I was kind of doubting you, and you said, wait, look at this. And then how it felt to be able to lead your class that way to show them a different way to do math.
Well, I felt like I was wrong, but then I looked back at my numbers again, and I saw that I got the right answer that she said, that Mrs. Dixon had said. But anyway, I felt like I was wrong originally, but then when we checked back over my answers, I got it right.
What did it feel like to be able to go up and explain all of that to your fellow students?
It felt really good because I felt like I was helping out.
How does this change you going forward as a mathematician?
I would say it gives me a new strategy because not everybody is like the same, and their thinking is not the same. So what I did is I figured out a way for some people, not all people, because not all people understand it this way.
Well, thank you so much for watching. I hope this has inspired you in your own teaching, whether you teach math or another content area. Go ahead and hit the like button. Subscribe to my channel if you want to see more videos that talk about how we can grow ourselves as teachers and learners of math. Are you ready for more?